Welcome. This is Lab 1 project as a part of the EE542 Internet and Cloud Computing for Fall 2018. The project is to get a hold of what DETERLab is and how it works, and this is done by following the core guide provided for the assignment. Let's go over DETERLab and let's see what it is. The DETERLab facility is located at USC ISI and UC Berkeley, which was funded by the National Science Foundation and Department of Homeland Security. So it has around 200 systems working in parallel, providing service for the users on testing networks. And it's built on a technology called EmuLab, which is a simulator, but the DETERLab is moreover like an emulator. So this is the setup on where it is, and there's a 1 gigabit per second dedicated link between ISI and UC Berkeley, and all the users can log in through a secure shell and then create their own nodes and perform tests. To design our topology, we would use a file format to describe what's going on or how the setup is. So the NS file is a network simulator file which is used, but just not the simulator, but the DETERLab uses the simulator file to emulate our nodes into real systems. So the format is as follows. First, we would have to set the simulator. So we use a command set ns, and we create a new simulator, right? And we mention a source compact file, so tb compat.tcl. So these are the settings. And now let's say if I have to have 4 computers inside my network, and I would have to create 4 nodes. So set node A. So these are just my temporary numbers. Node A is a temporary name, which will then be translated into a real name once the experiment is swapped in or when the experiment is created. So that is why we mention a $ns node. And then let's create similar nodes and name it node B, node C, and node D. So this creates 4 nodes with virtual names. And then now, having these nodes, we need to create links to interconnect all these nodes. So set link 0. So it's my first link, which has $ns duplex link. So this is a duplex link where both nodes can talk to each other, and then node B and node A. So this is a duplex link between node B and node A with 13 megabit bandwidth, 15 milliseconds delay, 30 megabits bandwidth, 50 milliseconds delay, and drop tail. This is the type of queue, so whenever there's overflow of packets, the tail is always dropped. And tb set link, so this goes to the tb file and sets the link. So set link with loss, of course, and for the link 0 we have a loss of 0.01. We can change the loss, and which will be shown later on in the video. And this one is to have a LAN connection, local area network between multiple nodes. ns, right, make LAN. This is a new command which makes the LAN node D, node C, and of course node B. And then all of these with 100 megabit bandwidth and no delay at all. Currently, the limitation of delay between 2 nodes is should be more than 2 milliseconds or 0 milliseconds, because DETERLab is still working on setting it between 0 and 2. because the systems are not capable enough to predict a model which can model the less than 2 millisecond delay. And then for each node, there are multiple operating systems which are supported. So some of the operating systems which are supported are FreeBSD, Ubuntu, Windows. So let's load Ubuntu into all our nodes, right? And so node OS means operating system for each node. So my node A would have Ubuntu 16.04 and the standard package. So let me copy this for all my nodes and D and C. So these are the operating systems for my node. Now we also need to enable routing between all these nodes. So we have this command $ns network simulator rt-proto means routing protocol, rt-proto, which is as of now static. There are many different settings in routing, which we will go over in the last section of this video. And the last command as of now would be ns run. So this basically completes our basic setup for the ns file. Let's upload this into DETERLab and then create an experiment. Let's see how it works out. We're writing our ns file. We come back into DETERLab, we log in and try to create a new experiment. So this is the setup of DETERLab, and we already have an experiment running, but that's for later. And let's create a new experiment by going to experimentation, begin an experiment, and this is under the project EE542. The group is default, and name of the experiment would be new exp, and description would be EE542 Lab 1 assignment, and uploading my NS file, the file that I wrote. Let's go to downloads, to NS file, choose, and idle swap. Let's set it to 1 hour for now, and swap in immediately as possible, and submit. Once we submit the NS file to DETERLab, it goes over the syntax and tries to set up everything. We probably need to wait around for 10 minutes so that it gets all the available systems and it gets swapped in immediately. And after that, we receive a similar email with all the settings that we have mentioned. And also it's created these many nodes, and each node running Ubuntu's here, and with each physical IP address, real world IP addresses mapped here for each node that we have created. And it also mentions the delay, bandwidth, and loss. Once we are swapped in to the experiment, and once you've got an email, we can go to my DETERLab and check all the settings of the project. So the state would change to active. When we go inside the experiment, it gives you all the details, and these are the options. We can modify the traffic shaping here. That means for all the nodes that we have, we can change the delay, change the bandwidth, and also change the loss. Right now I've set it to 30% loss of packets. And if we go back to the experiment, we can also see the visualization of the nodes that we have set up here. This would be the emulated setup with all the IP addresses, and the details of the project would be here. This would give us the details on the different nodes, their name and their IP addresses, the loss, and what kind of operating systems they're running. We will log in to the systems at DETERLab using SSH. So it will be SSH USC DETERLab. Enter the password, and we are in the system. Now we would have shared folders across all the nodes, and also shared folders across all the users inside each project. So let's do a pwd and check. So this is a specific user, and we could also do a project and EE542. This would be our project folder. So cd right, and we can log into each of the nodes as though they were a different system by writing the node address as ssh node a dot the experiment name dot project name and isi dot deterlab dot net. So we're inside node A. So to check the kind of operating system it's running, we do a uname. So this is running a Linux system, a 64-bit architecture with Ubuntu. And we can log in the similar way to all the nodes. And if we have to log out of them, so we just type log out and we are back inside the user shell. Is installing automatically a few packages and also unzipping a few tar files, and also starting applications automatically once your systems are swapped in. So for example, it's just like startup applications when your operating system boots. That's what we are trying to achieve. So RPMs are packages which are managed by RPM package manager. So the command to do that would be tb set node rpms, right? And we mentioned node on specific node where we need that specific RPM to be installed. We have a proj and EE542, the path of the RPMs, and let's go and check which RPM we already have. It would be this. Copy and paste it here. That would be the RPM that we're trying to install, and the next command would also be to add to unzip a tar file, and to do that the command would be tb set node and tar files, and tar file into which specific node and in which specific, so users USC 42ch/. So this is a specific location where I want my tar to be unzipped, and to specify where the star file is located. And to do that, let me check what is there inside it. And one of these tar files is our package, just a sample, and we will show you how it is being installed, where it is being installed eventually. And the next command would be to start a program, but we would do that once these two steps are completed. After we modify the NS file to run RPMs and unzip tar files, we update it inside the DETERLab, and it would work and send us an email again which says that this RPM is being processed in the specific node that we mentioned, and also that the specific tar file is being unzipped from that specific node. So to verify that, we can go back to the terminal and then check at the specific location where it is being installed, and we would and the result is that we would find that specific tar file to be unzipped. This portion of the video explains how we can make applications run automatically as soon as we are swapped in. So these two are the commands. Let me modify my ns file with this, and we are trying to run the shell file which is provided for us on node B, and then generate a log file. Okay, and then and then we go and modify the ns file, and after a while we get an email like this which says, okay, this thing is being executed when you swap in. Now I've logged into my node B using the terminal to see if my program has run or not. So initially it would be the output is redirected to a temporary folder. So what we do is go to the temporary folder, tmp and ls. So it's created a new log, and then just to check what's inside it, I just vi, and this is what has been run as soon as I swap in. Other functions include setting up routing in different ways. So this is the syntax, and there are many protocol options. As we remember, we said static, and now we have 4 different types, which is session, static, static old, and manual. So once we override it to manual, we'll have to set up all the routes automatically. So, and the next hop and destinations and everything. So node, client, and all these needs to be set up. So these are the things. We've implemented all these things, and to make sure it works, also in the presentation it's been included here, all the commands. The most important command is obviously add route, as we see it many times. Some of the extra stuff which we might need in the future are the ns command extensions. We would have to understand this completely in order to use the DETERLab in an efficient way. Duplex links, nodes. And so we are almost at the end of the video. So thank you. This completes the first lab assignment. See you in the next lab assignment.